Hello, everyone, and welcome to the fourth professional masterclass of the Gemini Academy. Today, we'll be exploring generative AI with the Gemini API in Vertex AI. And before we begin, I'll just quickly walk you through the process of the program. So I believe that you already know that GenAI Academy is the first phase of the GenAI Exchange program. And this program is specifically designed to upskill the Indian developers in AI through comprehensive learning resources, hands-on projects, and expert guidance. So this program has two phases: the GenAI Academy, where we offer free of cost AI courses on Google Cloud Skill Boost platform and virtual master classes with Google experts such as this one. Then post July, we will be starting with the GenAI Exchange Hackathon, where you can build AI solutions and compete for prizes. So basically, you can apply the knowledge that you gain from this academy into the hackathon. Moving on, as of now, we already have crossed over 240,000 developers in the academy, and they have all started their learning journeys. And this overwhelming response from the Indian developer community is truly inspiring because it speaks volumes about their eagerness to dive into the world of generative AI. And under the GenAI Academy, you get access to 5 AI courses on the Skill Boost platform. While you're required to buy credits to access these courses normally, but under this program, you get credits after completing just a few simple steps. I will walk you through these steps in just a bit. And once you get these credits, you will be able to use those credits to access the courses. Now, this is what the program is all about. The Just one second. Yeah, so this is what the program is all about. The first thing here is the Google Cloud skill badges and completion certificates. So, like I said, there are 5 courses, and each course that you complete, you get a skill badge. And upon completing all 5 courses, you get a certificate. So that is one thing that you can really show off on your LinkedIn and on your CVs because it really holds a lot of value. The other thing is you can learn from the best in industry. You can attend workshops, mentorship sessions, and these masterclasses with Google experts and gain insights into the latest AI advancements, be at the forefront of the industry. And third thing here is the leaderboard and exclusive opportunities. So while you are attending this masterclass and while you are a part of this academy, we have gamified the entire process. I will tell you how, but we have gamified this entire process, and you are a part of a leaderboard as of now. So if you climb the leaderboard high enough, you get access to a lot of exclusive perks, including a lot of in-person events by Google, some merchandise, and so much more. So I'll just tell you, I'll just tell you how you get these points. This is the process of getting the points. So each course that you complete, you get 100 points. So that's like 5 courses, 500 points straight. Then every time you attend a masterclass live. So for example, if you are attending this live, you get 20 points. If by any chance you're unable to attend the live masterclass, but you watch a recorded masterclass instead, you still get points, but you get 10 points. Then this is about the courses and the masterclasses. But now every time that you get a skill badge, every time you complete a course and you get a skill badge, you get 30 extra points by posting a blog on Medium. You can probably talk about your learnings and how the experience was. And similarly, you can post a skill badge on LinkedIn as well for 10 more points. So a total of 40 points you can get in addition to completing every course. So this is how you get the points. But to get those points, there is one thing that you have to do. And I will walk you through that. I'll just share my screen again. Yes. So every step that you take has to be documented and everything has to have a record, right? So this is the dashboard of your entire program. Now here if you see, this is the roadmap, which means that this gives you an exact step by step of what's next in your entire process. So as of now, what you have to do is you simply have to register, submit your Skill Boost public profile, right? Now the Skill Boost profile has to be public, otherwise we will not be able to process it further. And this is really important because you will get your first 100 credits. We will be allotting you 100 credits to take the courses. So how you can take those credits is you have to submit your Skill Boost profile and you have to complete two courses, which are the first two courses, which are Prompt Design in Vertex AI and Build Real World AI Applications with Gemini and Imagine. So these are two courses which require absolutely no credits for you to access these. So you have to take these two courses. And then what you have to do is you have to go to the Skill Boost and Skill Batch Submission tab. Click on it, go down, submit your Skill Boost public profile. So you enter your email and you share your public profile link and then you hit submit. Next, you go to the Prompt Design in Vertex AI tab. Here you submit again your email and your skill badge link and then again you hit submit. And then you go to the third one, which is the second course, the Build Real World AI Applications with Gemini and Imagine course. And you do the same thing here as well. So once you complete these three steps, the first is submitting your Skill Boost public profile link. The second is submitting your skill badge for the first course and submitting your skill badge for the second course. These are the three steps. Once you complete these three steps, within 8 to 10 days, you will get some credits. You will get 100 credits. Using those credits, you can access the remaining three courses for free. So it's really important for you to at least do these three steps to get the credits that you need to cover the other courses. So that was for the credit part. Now, let's get back to the point system, right? Let's not get confused between credits and points because those are two completely different things. Credits you need to complete the courses, and points you need for the leaderboard. So I will now take you through the how to get the points. Here you can see your social media submission tab. So every skill badge that you post on LinkedIn or every article that you post on Medium, you can simply come here and select the course, whichever course that you did. For example, you completed the first course, which is Prompt Design in Vertex AI. You enter your email, you share your LinkedIn post. So if you have posted on LinkedIn, you share that post link here, and then you share your Medium blog post link here, and you submit. Now, if you have done the other course also, if you have done another course, you can just click on Add Submission, click on the second course, and then do the same steps here, and then you can hit submit. So you can add a submission over and over again until you have all five. So that is not an issue at all. For every course that you finish, you can do this. So this will get you the points that you need for the leaderboard. And same goes for the skill badge submission. Every time you submit your skill badge, only then will you get your 100 credits, 100 points. So there are five courses. These are the five courses. And for each course, you have to submit your skill badge here for the points. And every time that you submit this, we will process the points and then you will go up the leaderboard. Great. So now, just one second. Yes. So that was it for the point system and the credits. I hope it's clear. And if you have any queries about the point system or the credits and everything, so you can just write to us at Gen AI Exchange Support at hacktoskill.com. I will be posting the email ID in the chat box as well. So until then, now I would like to introduce you to our speaker for today. His name is Sanjit Mehta, and he's a practice specialist, machine learning and infrastructure at Google Cloud. So I'll just get him here. Yes. Hi, Sanjit.
Hey, hi Asma. Good evening.
Good evening. Thank you so much for being here. And I'll just quickly
Awesome.
put you
Thank
on
you.
the screen. Yeah.
Awesome. Thank you very much. So good evening to everybody, and thank you for joining in. Just a quick introduction. My name is Sanjit Mehta, and I am a practice specialist for machine learning Artificial Intelligence and Infrastructure, part of the AI practice team in APAC within Google Cloud. So today we'll be, sort of focusing on exploring the Gen AI SDK within Vertex AI platform. With that, what I'll do is, Usman, that's okay. I can just put my screen. Thank you. All right. So we'll just do a quick recap for folks who would have. So as Uzma mentioned, right? So this is like the fourth masterclass. So just wanted to do a quick recap of whatever's been covered by my colleagues and as part of other master classes so far. So there was one session which focused on developing Gen AI apps with Gemini and Streamlit, which introduced you to Gen AI and how you can develop and deploy an app in using Streamlit on Cloud Run or Cloud Run functions, etc. The second one was focused on, sort of building applications with Gemini and Imagine using Vertex AI again. And the last one, the Masterclass 3, was focused on prompt design in Vertex AI, which sort of walked you through how to write better prompts, what are the key things that you should take care of, and how you can use AI to, in fact, write better prompts again using the Vertex AI platform. Today's focus is going to be on, sort of developing applications using the generative AI SDK as well as Vertex AI. The skill badge that sort of aligns to this is called Explore Generative AI with Gemini API and Vertex AI. And today's agenda, we'll try to cover the key things that are part of the requirements for that particular skill badge. So our agenda will focus on how do you get started with Gemini API and the Gen AI SDK using either Vertex AI Workbench or collab notebooks and things like that. The other thing, next we'll go on how to use the multimodal part of it, and understanding the key API and SDK concepts, moving on to the multimodal capabilities of this particular model, and lastly, focus on function calling. Okay. So with that, let me just start ahead with introducing what the Gen AI SDK is. So the great part about the Gen AI SDK is that it's basically available as open source. You can always go to GitHub and search for the Python Gen AI repository, as well as go to Google APIs or github.io, the Python Gen AI for the larger documentation. So let me just explain what this is, sort of support, right? So the idea here is that in your previous sessions, as well as when you interact, sort of with different AI models, you tend to use an interface. That interface could be either a chat interface or an app or something like that to interact with the model. Here is like if you were to develop an application, then you need an SDK to be able to develop that particular application and then programmatically be interacting with the models that are underlying there. The Google Gen AI SDK simplifies how you interact with the Gemini family of models, as well as including things like the Imagine models for generating images and Veo 2 for generating videos. As I mentioned, the documentation is very, very comprehensive and provides all the necessary, you can say, requirements that you need to sort of build an application using the SDK yourself. And it's open source, so you can always browse through the source code on GitHub. Moving ahead, how do you use the API? So obviously, you can always go into the Vertex AI workbench and start coding. You can also use the Colab notebooks or your local IDE to start and develop something, and then move it to Vertex for operationalization. In terms of API, you have two ways to use it. Again, using the API key. So how do you get the API key? You can go to aistudio.google.com and click on Get API Key to get your API key. The other, okay, I think folks are requesting for full screen. Sorry about that. All right, there you go. Yeah, I hope this is better. All right. So, moving ahead. So I just wanted to say here that you basically either generate an API key and you can go to aistudio.google.com and generate an API key to be used with your applications. However, that is primarily, sort of recommended primarily for prototyping and development. Once you want to move your applications to production, you use the Vertex AI setup. For most of the labs that you have as part of this particular skill badge, we will be using the Vertex AI workbench setup. Okay, moving on. So let's focus on understanding the key API concepts. So I'll now switch, sort of between my Vertex AI notebook, as well as this particular presentation to talk about a few concepts. So just to recap what you've discussed so far, you have the models. So far, we have been interacting with the models primarily through an interface that was built by someone, either a chat interface or an app, etc. But this particular session or this particular class is focused on how do you build your own apps using the Google Gemini SDK, which makes it very, very easy to interact with a wide variety of Gemini models or a wide family of Gemini models, which are sort of powering your AI application. Moving on. So setting it up, right? So that's the first thing. So as I mentioned, the library that you sort of set up is called Google-Gen AI. The documentation is available. You just need to sort of again Google Gen AI library. You will have the source code as well as documentation available for you to start developing. Let's do a basic quick install, and we'll just do a straightforward prompt, okay, before we discuss some of the foundational things around this. Your project ID and location. So this, again, as I mentioned, you can always work with an API key. You can always go to aistudio.google.com, get an API key and work with it. But as I mentioned, that, it's fairly, I would say, recommended to start using Vertex AI Workbench once you have to actually deploy or productionize an application. For prototyping and development, an API key would be fairly usable. Moving ahead, the model that we plan to use for today's session is the Gemini 2.0 Flash model. Again, I think my colleagues in the previous master classes have definitely, touched upon the point that we have newer models like Gemini 2.5 Pro as well as 2.5 Flash models, which are doing amazingly well at the leaderboards. But nevertheless, for this particular session, we'll focus on the Gemini 2.0 Flash 001 model. Now, the simplest thing is you basically just tell it a prompt, right? And you just give it the model ID and you want to generate a content. That's the I would say the most basic stuff that you would do. Okay. So essentially your prompt or your client is created once you establish a connection with Vertex. Once your client is created, there are three things that the client needs to generate the content. It needs one, the model. The second one is basically your content, which is essentially a prompt. And the third thing we'll come to later is the config. Okay. So at a very, very basic point, so what we are trying to do here is we are trying to generate content, and we have just passed it a prompt and it is able to reply with a particular response, which says that, okay, the largest planet in our solar system is Jupiter. Okay. Now I'll go back to my slide to talk a little bit about the other things. Okay. So I believe that you would already have gone through this particular part when you did the prompt design course. Is we have a concept of system instructions and the prompt. So essentially what system instructions are is basically telling the model how to behave, what kind of task it's supposed to do, what is the objective, any guardrails that it is supposed to follow, how does it interpret the user query, any external data sources, etc., that it needs to use. Anything that you basically tell the model to do is essentially called quote unquote as system instructions. Now, once you have a system instructions, sort of programmed into your configuration, any new query that comes in would essentially follow the system instructions for each one of this particular uh, user queries that come in. The second part is, and this is where we will get right now into it, especially for the multimodal models, right? So we have discussed this in our previous sessions, is that Gemini is ground up multimodal. So what this essentially means is that it basically can interact with all your modalities in one shot, meaning within a given prompt, you can pass it a video, audio, images, text, documents, etc. And it is able to collate everything together and provide a fairly rich response in return. So essentially, because the whole concept of, you can say, natively multimodal applies to Gemini, so the way that we construct a content when we pass it into uh, when we pass it into the API, we call it essentially parts. So each part is essentially, you can say, a piece of the content that you want to pass to Gemini to interact with. So we'll quickly get into the multimodal prompting part of it. So here, if you look at it, so essentially a content is an array of parts, and you have something like a file URI. So I'll just show you what this file essentially contains. It's a very simple image of couple of, I would say, meal boxes or lunch boxes. Moving here, right? So you have to tell it that, okay, from this particular URL of which the MIME type is image, you just have to write a short and engaging blog post. So this is essentially one of the parts which contains the image URL, and this is the text part, which essentially tells it what it needs to do. Okay. So once we run that, the idea here is that it would be able to understand the image and it would be able to fulfill your request in terms of writing a short and engaging blog post based on the picture. Okay. So now how does it help? So essentially, imagine this, right? So if you're building an app or if you're building an application, so it's wherein you want to provide a capability where somebody should be able to snap a picture and then ask questions on top of the picture as well as additional text-based instructions that are there, you should be able to do it without any issue whatsoever. Okay, moving ahead. So we'll talk a little bit about, I think, yeah, okay. So we'll talk a little bit about the system instructions part of it. Okay. So as we discussed, the whole idea behind system instructions is to tell the model on what it should be doing. So usually we divide our system instructions into things like roles, objectives, tasks, and output formats. Okay. So this is your role. This is the objective that you're supposed to fulfill. These are the tasks that you do. And then this is the output that you're supposed to generate. Now here, the system instructions that we are providing is that you are a helpful language translator and your mission is to translate text in English to French. Now, the question is, how do we tell or how do we pass the system instruction? So as I mentioned earlier, your prompt consists of the system instructions and thereafter it consists of the prompt, and the prompt will keep changing, right? So it's essentially user input. So a user can give you n number of what's that called? Yeah, so a user can give you a number of inputs, but you have to essentially be able to translate. So here, if you look at it, each time the system instructions will stay constant because it's basically how the model is supposed to respond to user inputs, and the user input shall keep on changing. So the way now I'll introduce you to this part. So we already discussed two parts already. One is the model, which is essentially the model ID. It can be anything from the Vertex AI model garden. Uh, Once you give the model ID, you have to give the content. So as we discussed, a content is an array of parts. Parts could be derived from text, images, audio, video, documents, etc. And lastly is the part which is more around the configuration. Okay. And system instructions are a part of the configuration. So in the configuration, we pass the system instructions. And again, you can make it as complicated as you want. And the AI should basically be able to adhere to it when it is answering user queries and questions. Okay. So in this particular case, the system instruction was, you are a helpful language translator and just translate English into French. Okay. So if I just change this, today is Thursday, May 15. Okay. So it just basically changes the output and the system instructions remain constant. Moving ahead, we'll talk a little bit more about the additional content configurations that are available to you. So I think each one of us, we would have played around with a lot of chat-based interfaces as well as, different AI studios and stuff like that, wherein I think these terminologies have been fairly common. Temperature. So essentially it says that lower the temperature, the more deterministic the response, higher the temperature, the AI is able to generate. You can say responses which are less probable or response sequences which are less probable. Same goes with your top P and your top K, which is related to how tokens are sampled towards the last layer of that particular neural network. In terms of, I think the key things that is here important to understand is the max output tokens. So max output tokens basically limit the number of tokens that get generated when your response gets generated. So let's say, for example, we try it with 100 output tokens. So I'm just asking it, okay, tell me how the internet works, but pretend I'm a puppy who understands only squeaky toys. So here, if I generate this, so it stopped at 100 tokens. Okay. Now, if I make this a little bit more and make it, let's say, 250 tokens. So essentially, what's going to happen is it'll increase the number of tokens. So this is usually there are default values for each one of the models. To the best of my understanding, it's either 4096 or 8192 tokens that get generated whenever you make a call to the model. But the point which we are trying to make here is that it is configurable and it is all part of the generate content config. Okay. Moving ahead, once you have this, the next part is essentially the safety settings and the safety filters, which also again fall under you can say the content config. So the idea here is that for different categories of safety settings, you have to provide a threshold. The default, I mean, you can say if you, let's say, for example, I mean, the lowest threshold is you can just put it as none, and then you have thresholds which says block medium and low, block high, block only high, and so on and so forth. So what I mean by that is, let's say, for example, when I'm generating a particular output which says that write a list of two things that I might say to the universe. Now, if I generate the safety rating for it, so it basically has categorized it as severity negligible. Okay, so because it is essentially not blocking. I mean, it's only blocking the high part of it here that because the output was negligible. So essentially, you're not blocking the output at all. So you're basically having a particular safety output for the text output that is generated. And this is configurable. The whole list of categories is available as part of the documentation in terms of what safety category settings you can apply whenever you are writing the uh, what do you call when you're writing the prompt as well as your AI application. Okay. Now, one thing which is we have done so far, right, is basically we are generating content. So it's what I would call a single shot interaction, meaning I give it a prompt and it gives me a reply. Okay. It's not, you can say, interactive. Now, if let's say, for example, if I take this, right, so today I'm just translating this. So if I say translate my previous sentence, three, then it won't probably understand because it doesn't have, it just translated this itself, but it doesn't have the context to understand that, okay, I spoke to it before, now I'm coming back to it. So essentially, there's a concept of a context. Essentially, what happens is that when you do a single shot, or you can say a single interaction, you basically ask the model to do something, and then it does that thing, and that's it. It sort of stops there. Uh, Now, yeah, so safety category is for model. Yeah, it is for what to ensure that model does not generate explicit content. Yeah, that's correct. And again, the safety categories are defined in the documentation. We are only showing one, which is the dangerous content, but there are different types of safety categories. Maybe towards the end of the session, I'll just get back to this and search the documentation for it. Moving ahead. So as I was saying that when you are interacting using the generate content function, you basically are talking to the model, and then the model gives you a response, and that's that. Okay, so there is no like a continuous conversation that is being maintained between the user and the model. Now, that is where the multi-turn chat comes in. So why do you need multi-turn chat? It is because you basically want to continue a conversation with the model such that it is able to recall the previous context that you had sent to it. So let's take this particular example. So here the system instruction is that this particular application is a software development application which generates high quality code in any programming language. So the user needs to basically uh, help with the programming language, or it might generate something as default. So let's say, for example, I send it a message. Okay, so if you think about it, essentially what's happening here is that I opened up a continuous stream of a conversation with the client, and I sent it a message which says that write a function that checks if a year is a leap year. It wrote that particular function. Now, here I ask it to generate or rather write a unit test of the generated function. So I didn't have to tell it that this was the function that was output. The reason I didn't have to tell it is because this is a conversation that maintains a memory buffer or a context, to be precise. So essentially, as long as this particular chat session continues, you should be able to easily recall the context that you had set earlier. So let's say, for example, here you generated the code and you just ask it to write a unit test of the generated function without having to pass the generated function to it. Okay. So I think we covered this part, which is essentially the chat session. So just to recall, what we've covered or we've dived so far is we spoke two types of content generation. One is one shot, or you can say uh, uh, one call kind of a content generation where you call the generate content function and essentially it gives you an output and that's that. And each generate content, or in fact for even chat, you have three components. You have the model, you have the contents. A content is an array of parts. A part could be anything. Because Gemini is inherently multimodal, it should be able to take any type of parts, whether it's audio, video, text, images, etc. And lastly, it needs the content config. In content config is where you pass your generation parameters, you pass your system instructions, and you can also do a multi-turn chat overall. So instead of calling, so if you see here, the difference here is that instead of calling client.models.generate content, you basically do client.chat.create. Essentially, it opens up a continuous stream of conversation. Okay. Moving ahead, the next part of it is very interesting. So let's say usually what happens is that I think one of the things which is very, very common, specifically with any AI system for that matter, and this is where I think generative AI becomes a little bit different from our traditional programming practices, is that your output may not necessarily exactly stay the same every time you call the model. Okay? It might change here then and there a little bit, right? Even though you, let's say, for example, set the temperature to absolute zero and you try to generate I mean, most of the time would stick to the output, but then there might be an off case where, you might get a little bit off output compared to what you were expecting. And that is where we have the concept of control generation. So why do we need control generation? So basically, you need control generation if you want your AI application to interact either with other parts of your application or either with, let's say, for example, another system altogether, right? So whenever we develop APIs, we have the concept of creating contracts with APIs where I know that, okay, if I pass you this particular input, or this is the input you expect, and therefore you'll pass me the particular output. So essentially, managing that contract, making sure that whatever I generate is fairly controlled and aligns to my requirements is absolutely essential. And that is where the control generated output comes in. And here you have two approaches to provide it. So essentially, when we talk about control output, so we usually provide the MIME type as application JSON, meaning we expect the output to be generated as a JSON object. And the schema, either you can provide it as a pydantic model. So in this case, let's say, for example, I define a pydantic class, which is essentially a recipe which has a name, description, and ingredients, which is a list of strings. Or I can also provide it as a JSON schema, wherein I say that the response should be a type of array where you will have items, which is also an array, which will have multiple objects within it. Okay, so essentially you have two ways to pass the response schema to the AI application. One is either you can do a pydantic model, or second is you can basically define it as a JSON object. Okay, so the benefit of this is that whatever output the AI generates will ensure that it followed this exact response schema. Okay, so it won't essentially, sort of change the name of the keys, or for example, perhaps, change the data type, etc. It will ensure that it follows the response schema uh, such that you get a control generated output. So just we'll run this for example. So Here, if you say list a few popular cookie recipes, so it just outputted name, chocolate chip cookie, description, and ingredients, and it is a JSON object. Same thing if you try to do here. As I mentioned, you have two ways to do it. So this, even if you define it as a pydantic model, that's also fine. You can provide it as a JSON, what's it called? A JSON object schema. That is also perfectly fine. Okay, but the AI will ensure it will give you output in a controlled manner. Okay. Moving ahead, so again, so far, just to be on the same page, we discussed, generating the content. We also discussed control output and chat interfaces, or rather chat sessions. In certain cases, I think the thing becomes like when we talk about the generate content, it is like you basically have it in the way that when the whole content gets generated, it is sent to you over the network and you receive it. And let's say, for example, whether you print it or send it to a downstream system or you show it to the user, either way, you basically get the whole content once it is generated at the model side. That is where the other part comes in, which is essentially generate content stream. So the idea here is that instead of getting the whole content once your you can say generation is complete, you would start getting smaller chunks of data as and when the model starts producing output. So I think whoever in this particular set of folks have sort of used any AI chat interface, for example, Gemini as an app or AI Studio, etc., you would see that things basically, sort of it feels that the AI is writing stuff essentially. So instead of waiting for everything to be generated and then show to you, you essentially will have it in the form of chunk by chunk by chunk by chunk, such that it's basically interactive. Okay. Now to do that, you essentially try to generate a content stream instead of a generating content. So essentially you will basically see it like this. So it'll, again, as I scroll down, I'll just do it again. So it basically, as it receives the chunks, it start printing it. So it doesn't have to wait for the entire output to, sort of come. It can start generating. Okay. So this is essentially generating the content stream. Now here, yeah, I think the async part is also there. So this is a little bit different compared to the generation of content stream. So our models, you can say package or the models module within the client offers two ways of generating content. One is the sync way of generating content, which we already saw, right? Which is essentially client.models.generate content. However, for an application, when you are developing it, you necessarily don't want a blocking content generation method, and that is where you can use the async IO part of our client essentially to generate content which is async. So what happens here is like if I just remove a wait, so sorry, apologies. So it will just complete quickly. Okay, and then I can use the response to as and when the response arrive. However, if I just put that's back. So it will wait for this particular async process to complete, and then once it receives the response, it prints it. So the idea here is that if you're developing an application which has multiple screens, etc., and you want the content of the model to be loading in an asynchronous manner, you should be able to use the AIO models to generate content. Okay. Moving ahead, I think we'll talk a little bit about certain metrics from a content generation perspective, which I believe sort of is fairly common lingo. I'm sure you would have heard it a lot. So just let me move back to the presentation to talk about certain metrics when we talk about the content generation part of it. One is the token count, right? So essentially, your token count is important to be able to figure out that I think most of the pricing, etc., or even for that matter, latency, when we try to say the number of tokens output per second, etc., is dependent upon the count of tokens that are being generated. Okay. Now, I believe we've already discussed in our previous sessions that tokens are, you can think of it as a portion of a word or a word in itself. There are tokenizers, which essentially break down a sentence into a number of tokens. We'll again go through the example, but the key metrics that we tend to take into account is your token counts or the types of tokens or the tokens which are actually generated. the total output tokens, the time to first token. So time to first token becomes extremely important for user experience, primarily because when I showed you the content stream part of it, right? So one of the reasons why, let's say, for example, when you're interacting with AI chat interface, right? So instead of you waiting for the whole content to be generated, you would rather want it to, sort of start telling you things, right? Or start generating content as soon as it's able to. And that is where your time to first token becomes extremely important. And when you do content stream generation, exactly that's what you achieve. So you start seeing what content or chunk is generated, you print that chunk out, and you continue printing it out till the entire response is done. Okay. Moving ahead, you have your tokens per second. So it's essentially your total output tokens divided by total generation time is essentially your tokens per second throughput. Okay. And I think these days the models are fairly, you can say, responsive, and the latency has gone down. And there too, I mean, it depends on the kind of model you use. You have different families of models. So you have the flash model, the flashlight model, which are extremely fast, with their latency going down into 500 to 1300 milliseconds, in terms of your content generation. And then you have reasoning models as well as pro models, which essentially, you can say, think quite a bit before they generate the content. So it depends on the kind of use case you have, is where you fit the appropriate model. But coming back, so, so yeah. So coming back, you basically have these two methods that are available to you to do token counting as well as identify the tokens that have been provided to you in your client. So it says that, okay, for example, if I say what is the highest mountain in Africa, so let me just bring up this. Come on. Okay. So substantive response for next. Yeah. So it says that the highest mountain in Africa is Mount Kilimanjaro, located in Tanzania. So it says that it ended up generating, I think, almost 9 tokens or something. Okay. The next part is moving ahead. So the compute tokens, so as I mentioned, that tokens may not always be, uh, for example, the tokens. So this is actually telling you the tokens which are passed here, and then you can get this particular output and you can get the tokens for that. In terms of compute tokens, it's technically telling you how many tokens you have passed to the model. Okay. And then there is, I think, a library called tick token or something, which you can use to count the number of output tokens that get generated. But essentially, the long story short here is that whenever you're building an application, you need a manner in which you're able to count the tokens that are available to you. Sorry, that you're sending as part of the prompt and the tokens that are getting output. And essentially that sort of your objective should be, I mean, try to, sort of reduce your time to first token as much as possible to improve user experience. And again, there are models which essentially help you do that. And the other thing here that matters is in terms of, again, the pricing part of it. Usually the models are, or the API charges essentially happens at the whatever unit of currency divided by the number of tokens that get generated, or per token, per number of tokens that get generated. Okay. The function declaration part I'll come to a little bit later because we, I think, have a separate module for that altogether. But I'll try to take a look at the caching part of it. Essentially, content caching is, again, it's available to use directly via the client itself, wherein you should be able to cache the content that you have provided it. In this case, there are two PDFs that have been provided. The benefit of caching the context is if you have to do repeated question answering on top of the same content. So let's say, for example, in this particular cases, we have two PDFs which go into the context of this particular client application. And if I just cache it. So what will happen is it will maintain that in memory. The TTL, or time to live, is 3600 seconds, which is essentially 1 hour. So it will stay in the cached memory for 1 hour. So the benefit of this is that you would not have to send, or rather resend, this particular context again and again and again to the model, which will save you obviously the token cost, your network bandwidth, the latency, etc. So it overall help you, sort of give a much better low latent user experience, and also of course save in terms of the bandwidth, network IO and whatnot. And if you look at this, right, the entire focus is that you should be able to cache this content and you should be able to query on top of it. So if you see, so I can just ask it a question and it will generate a response using the content that has been shared to it. So it doesn't need me to share the content again. So I just shared it in the cell that's here. I can just ask the question on top of it. Okay, so I can maybe uh, can summarize it. So it should be able to do that. And then again, just to repeat myself here, the idea here is that you don't need to send the cached content or the cached context again and again to the model. It basically takes care of it once you have essentially established a cache. Okay. Yeah. So again, it just summarized it without me telling what to summarize. Okay. Again, I can delete the cache. Okay. Moving ahead, the other part is going to become interesting is batch prediction. Now, we discussed a lot of things, which is essentially, you can say, uh, how do I put it correctly? Uh, in a notebook where I have multiple generate content loops and things like that. Now, usually what happens is that it's a high possibility that you want to run, your AI application as a batch on top of, let's say, for example, if you have a use case wherein you are supposed to maybe extract information from a number of documents that get generated, or perhaps let's say you have to summarize different news articles that get written over a day, etc., then you don't really want to sort of do it in a sync way. You want to write a batch process, invoke it once the data gets available. Your data could also be lying in certain GCS bucket and whatnot. So you just want to write a batch prediction, invoke the batch prediction, and then it saves the results onto a GCS bucket again. So you don't want to like me having a sync program to be able to do that. And that is where your Vertex AI batch prediction part comes into picture. So essentially, the way that we prepare the input is in terms of JSON lines object. So think I'm not sure if I will show that. Oh yeah, I don't think. Okay. Yeah, I'll probably try to find this particular one, but nevertheless, I think you folks can also copy it onto your local. This is a sample data, so it's available. So here you have two input objects consisting of two images, if I'm not mistaken, which essentially wants we have to essentially provide inputs with regards to that. Okay, here is it. So the content is that list the objects in an image. Okay, and so this is a JSON line object. So essentially, let's say for example, on a day, if you have let's say thousands of images, you just have to generate this 10,000 times with link of each image, right? It essentially forms your JSON-L file, and you submit it for batch prediction, and it continues in the background without you having to worry about it. Once the job gets succeeded, the output gets returned into the GCS bucket. Okay, so essentially that is batch prediction for you. Okay, now essentially, yeah, again, it's basically allows for your job to complete. Blah blah. So it started running. Okay, so all right, so uh, that's from the batch prediction, and then there is a short, I think, cell about embedding models. So one thing which I wanted to, highlight is that your embedding models are usually basically a little bit different from your large language models in the sense that the whole purpose of an embedding model is to take a bunch of texts, or rather a text string, you can say paragraph, etc., and then give you a vector in return. That vector represents a numerical representation of the text that you provided it. Um, and the key uses of embedding primarily has been, so far in terms of semantic search and retrieval and stuff like that. So essentially, it basically helps you to be able to, store your embeddings and retrieve the documents based on a query that user would provide later. So as I mentioned, that Google, of course, has a bunch of embedding models that we provide. And here, this is basically the example where it shows different contents and that get embedded. Okay, so this job is still running, but nevertheless, we'll move a little bit ahead. I think I'm probably going to run out of time, but nevertheless, we'll we spoke about multimodal part of it. I think the part which I wanted to, sort of focus a little bit more on is function calling, because this is extremely interesting as well as important when you're developing your own APIs or your own AI applications. The reason why this is important is because, so usually what happens is, of course, you know that large language models are trained to a specific date, right? So you can always go to a large language model chat interface and then be able to ask it, okay, what was your training cutoff date? And it will tell you, let's say, for example, it was September 2025 or September 2024 or December 2024, and things like that. So essentially what it means is that it is able to have the data stored and be able to respond to your queries up to the point till which it was trained or till which its training cutoff date was. Now, you want to enrich the capabilities that a large language model provides with your systems, your APIs, data sources. I think one of the key tools that sort of Google offers is essentially Google search grounding. So basically, in addition to using the large language models, internal knowledge and internal representation, you are able to use Google search grounding to make sure that your responses are accurate. So essentially, the whole idea of function calling or tool calling, or basically enhancing a model's capabilities with tools, is essentially to be able to provide it additional capabilities beyond uh, you know, the knowledge on which it was trained. Okay. And as I mentioned, this could be your, let's say, for example, a weather API. It could be a search API. It could be your internal systems API, wherein you ask it to probably fetch user data and things like that. Okay. So essentially, the reason here is it enhances the capabilities that large language models already have. And that is what essentially we call as function calling. Okay. Now, how does function calling work? Okay, this is going to be, as I mentioned, interesting. So I'll move to, I think this job succeeded. Okay, perfect. So again, once it succeeds, you should be able to see the data frame of what it created from the GCS bucket on which it created. Okay, and yeah, you have your embedding model, which gives you content embeddings and such. So, and I'll probably move to the function calling part without further ado. So the question becomes, how do you define functions? Okay, so this is interesting. So usually whenever we write a function, we always, as good developers, write the API specifications or doc strings and things like that of a function, which tells us what this function's name is, what it is supposed to do, the kind of arguments it accepts, and the data types it accepts, and of course the sequence of the arguments that it accepts. So within the GenAI SDK, we have a concept of types, and within types, you have function declaration as one of the types. Okay, so types is a submodule within the GenAI SDK. So if you go to the import statement here, yeah, so you basically go to Google GenAI types, you import function declaration. Okay. So function declaration essentially tells the model that, look, these are the functions that are available for you to use. Okay, so in this case, we have three functions, which again, this will be part of your skill batch labs. One is the get product info, which essentially, if a user asks you about a particular product, you can give the name of the product to this function, maybe a description or something like that, and then it should return with the product SKU. Then you will have location of the closest store and the ability to place an order. Right now, usually, sorry, I think I'm sorry. Sorry about that. Yeah, apologies. I should have done that. Okay, moving. I'll just repeat for the last 1 minute whatever I said, right? So you basically here have three function declarations. You have your get product info, your get store location, and your place order. So now imagine that you are part of a retail store or an e-commerce store, etc., and you have these functions, APIs, or ability to be able to do these things within your organization or within your application, right? But the model doesn't know. As I mentioned, the model has been trained to a particular cutoff date, etc. The model doesn't know about your context, your data, your products, and things like that. And that is where you enhance the capabilities of the model by providing it access to certain APIs, etc., that are internal to your domain, or it could be external APIs, open APIs, and whatnot. But the idea here is that you should be able to provide the available APIs or functions or tools, whatever you want to call it, to the model to be able to, append. extra information to generate a response which the user requires. Okay, in this case, we have three functions. One is your get product info, your store location, and your place order, essentially, which allows you to be able to provide or call each one of the APIs. Okay, and as I mentioned, so a function declaration takes into account your name of the function, the description of the function, and the parameters that the function accepts. My usual request to folks is whenever you define function declarations, try to be as expressive as possible, because that is what the model uses to predict which function to call when a user asks a question. Meaning, if I ask that, okay, what is the closest store where I can buy an XYZ phone, then it would be able to tell that, okay, call this function with this particular product to tell the customer where he or she should be able to buy the phone. Okay, so moving ahead, I'll just execute some of these code items. So let's say, for example, I define the tools. Okay. So if you see, I define the tool which essentially has three function declaration, the product info, the store location, the place order. Okay. Now, when I going back, right? So as I mentioned in your chat or in your uh, generate content, you have three things: your model, your config, your contents. In this case, we are just creating a chat with two things, which is your model and your config. And in the config, we are giving it the tool. And what is a tool? A tool is basically a set of the different functions that are available for the model to be able to append its additional data and such. Okay. Now, moving ahead. Okay. So let's say, for example, if I ask now, before I show you the flow, right? It's important for us to understand how function calling works. Okay. Because I think it's a brilliant So if you go to again the Google website, okay, or the cloud.google.com, etc. So one of the things which becomes interesting to understand for you is that you don't necessarily, for example, it's not necessary that the model will essentially execute the function. Okay, so I think this is what I wanted to share. So this is a very beautiful diagram. Okay. So usually what happens is, as an application, you give the function definition. Okay. Now, Gemini will basically decide whether it knows the answer already or it needs a function or a tool to be able to call to, tell you the answer. Right. So let's say, for example, if you just ask it, okay, can you describe pixel 9 for me? Right. So it's possible that it was already trained in terms of information for Pixel 9, and it can just generate the answer without having to call a specific function for you. Okay. But to tell whether a Pixel 9 is in stock at your store or not, it doesn't know that. So it needs to call a function for that. So it will tell you which function to call. Now you on your side know the function implementation. You know how this function has been implemented. It could be a service, right? An API. It could be just a Python function, etc. So you know the implementation details of the function. You will you will execute the function, you will get the result, and you will pass that result of the function call to Gemini. Okay. And then Gemini will basically generate a user centric answer or a user focused answer and respond. Okay. So essentially, the flow here is important to understand. You have a user asking a query. Gemini decides whether to respond with an answer or with a function name. It tells you that, look, I need this function to be called and output to be shared with me. You execute the function, share the output, and then it incorporates it into the wider answer generation and tells you the final answer. Now, moving back, right? So this is one way. There's one more thing which we'll come to, which is more like automated function calling, which I'll come to provides. But anyway, so here we are asking, do you have the Pixel 9 in stock? Sorry, do you have the Pixel 9 in stock? Uh, Apologies. Oh, sorry, I forgot to initialize this. So let's say it says this. So it will tell me that I want to call this function. Okay. So I'm supposed to call the get product info function with the argument product name as pixel 9. Okay. This is essentially what I need to do from my backend. Now, let's say, for example, let's assume that I called the function and I got this particular response from my internal APIs or my internal services that, okay, I have pixel 9, the stock keeping unit of pixel 9 is this and it is in stock, right? So I need to tell Gemini that this is the function response I got for the get product info function that you asked me to call. Okay, so once you send that, so the Gemini will respond saying that yes, we have pixel 9 in stock. Now you have to understand that this is all abstracted out from the user. It's basically your application that is doing all of this, right? Your application sending the query to Gemini, Gemini asking you that call this function for me, and then you calling that function, sharing the output of that back to Gemini, Gemini formulating the response and giving it to your user. Okay. Moving ahead again, so it's a bunch of function calls, etc. There are a lot of interesting examples. So I don't know if you folks have already started this, but if you go to the GitHub, which is basically your just share this quick tab. If you go to this particular GitHub where we have a lot of examples and notebooks, etc. for across Gemini. So function calling is one of them. You have a lot of interesting complex function calling examples here, which you should be able to try it on your own. Okay. Moving back. So we covered the function calling. Now here, as you saw, right? So I just passed it a function declaration. I did not pass it the actual function, okay? Which is, yeah, it is possible to connect through SQL as well. Yes, I think once you move on to agentic and stuff like that, I think, yeah, there's a lot of ways in which you can connect through SQL, or if you have APIs exposing your SQL database, you can pass it as a function declaration. It tells you the API, you do your internal execution, and then you just pass it back, okay? It works like that, and then or you can have it as a direct connection as well. That depends upon how your internal systems have been implemented. But moving ahead, the thing here it's important is this, right? That once, so here we were just simulating calls, and the tools that we pass are essentially of type function declaration. Okay, so essentially what I would like to call this as, these are basically stubs of a function which tell what is the name, description, and the parameters it accepts. One of the great things about Gemini or the Gen AI SDK is automated function calling. Okay, and automated function calling, I think currently works only with Python functions. So let's say if you have an implementation of a function. So in this particular case, you have an implementation of a function called get location. Okay, and internally, if you see here, it calls service to get the particular location for whatever address, etc., that you provide to it. Okay. Now you can essentially pass this as a tool instead of having to go through the cycle of defining your function declaration and then passing it to Gemini. So again, this is important to understand. So I'll just repeat myself. This flow that you saw here, right, which is essentially Gemini asking you to execute the function and you sending the response to it. If you have Python functions, basically we support what we call as automated function calling, which is you pass the function itself. Instead of the function declaration, you pass the function itself as a tool, and it essentially, the GenAI SDK takes care of calling the tool internally. So it manages it for you, right? So you are not responsible for executing the function. The API itself understand what tool needs to be called from the Gemini model, calls it because it knows what your function is, takes the response, passes it back, and gives you the final answer as is. Okay. Um, so this is where we conclude the function calling part of it. Again, there's a lot of information available, as I mentioned that the documentation is extremely rich, and I also showed you the place where you can go and look at a lot of other examples. So you just Google for generative AI, cloud platform samples, or even for that matter, function calling samples and things like that, and you should be redirected to the right GitHub repo for to be able to um, uh, sort of do this. Now, I think somebody asked the link for that. I think you should be able to just do generative. Let's go to the GitHub one. So if you just Google that, you should be here. Okay. And you go to Gemini and you have all the Gemini related samples, everything, right from your context caching to code execution, evaluation, function calling. Everything that we sort of studied today should be readily available to you. I think, as I mentioned, the documentation, the overall set of examples, extremely rich and extremely easy to understand. So, yeah, it makes life very easy for sure. Um, Moving back, okay. So I think the only part which I probably didn't go deeper into is the part with regards to the multimodal use cases. So I'll just take one example here, which is essentially doing video understanding. As I mentioned, I think Gemini has been built superbly inherently multimodal, and therefore you basically get all the different modalities from the get-go, and you don't necessarily need to sort of do it separately, so you can provide a number of things. So here I think let me just show a couple of examples specifically around this one, which is oh, okay, I think I need to execute other cells, sorry. I just promised something that should be done in another 5 minutes perhaps. So I'll just show you this, right? So uh, look at this one here. So we have groceries and prices, okay? And then you basically have consider the image, how much should I pay of the fruits, blah, blah, blah. So I'll just show you the images once. So this is the image for the fruits, okay? And then you have the price list. One second, I'll just show you that image as well. So you have this price list, which is apples for $1.50, bananas for $1.80, etc. Okay. So essentially, you are asking a bunch of questions, and as I mentioned, you have instructions, which are your system instructions, which we pass it as system instructions equals to instructions. Okay. Now, oh, sorry, I have to define some of these functions. Yeah. So here it basically shows that identify the fruits. It shows bananas and apples. There are three bananas, two apples. Bananas cost 80 cents, apples cost $1.50, and then it calculates the subtotal for you. So it basically, as I was saying, that it makes life very, very easy to have your model multimodal ground up, right? Because it's able to infer a lot of information from the images and do a lot of you can say interesting, it opens up a lot of interesting use cases for any AI applications for that matter. Okay. And I think we have one more example, if I'm not mistaken, for a video. Again, I'm sure when you do your skill badges, etc., you'll come across this where you have a video and it's able to extract tags and things like that. So again, the thing that differs is your MIME type. So instead of your MIME type being image JPEG or image PNG, you basically have a video MP4 in this particular situation. Okay. With that, um I'll stop. And again, thanks for sort of uh, yeah joining in, and thank you very much.
Hi, yes, Sanjay. I believe there are a couple of questions. Do you think we can take a few?
Sure, we can take the first. So I think it says two apples and three bananas. I think the image had two apples and three bananas, if I'm not mistaken. Um, just to be on the same page, I can just go and check back again. But I think, to the best of my understanding, it had two apples, three bananas, because that's the answers I got as well. Okay, three apples, two bananas. Yeah, it has three apples, two bananas. Yeah. So I won't be able to explain why the model is making that error, to be very honest with you. I think in certain situations it happens. So my request is to try a couple of times and see if it's able to give you the right answer. And maybe, we can do some of the learnings that we have from the prompt design perspective to be able to say that, okay, you try to identify or answer the question and then do something like a re-ask or a review kind of a thing, that review your response to make sure that it aligns with the image that was provided to you. So my request is to probably try some of these things once more and see if if you're able to improve the response of what gets generated. Um, for Vikram, sorry, I didn't understand the question. The whole purpose of creating transformers was the whole long sequence of multimodal capabilities as opposed to LSD and sharing. Sorry, I'm sorry, I didn't understand the question. Um, all right. Moving ahead, I think different between function call and function declaration. So function declaration is essentially you're telling, or rather you are defining what a function is. It consists of three things. It consists of the name of the function, the description, and your parameters and the respective data types it takes. A function call, on the other hand, is, let's say, for example, I have in my organization, let's say I am part of an e-commerce firm, etc. And in my organization, I have, let's say, 10 different functions to probably get product details, whether the product is in stock or not, what is the product price, and so on and so forth. Okay, so I will define all of these as function declarations, and I'll tell the model that, look, here are the different capabilities or functions that you have. Now, a user might ask a question that, okay, do you have, let's say, item XYZ in stock? Or let's say, for example, they might ask that, do you have any wristwatches? If you can show me some black wristwatches for that matter, right? So the model's job is to tell you which function to call. So that's a function call, right? So out of the n number of functions that are available to the model, it tells you that, okay, call this. Then you call it, execute it, and then return the response, which again the model processes and tells it to the user. As I mentioned, if you just give it as a Pythonic function, it also supports automated function calling, wherein you don't have to worry about executing it. Awesome. I think in video description, lot of error not accepted the when it is producing, not getting accepted. So I didn't understand the question. Built-in limitations and safeguards within Gemini. Okay, I think I'll move to that. One second. Safety settings. Yeah, I'll just share my screen. Okay. So if you just again Google for safety settings Gen AI SDK, so this is your different categories I was speaking about early on in the session: harassment, hate speech, sexually explicit images or videos, or for that matter, text, dangerous, uncertain integrities. So essentially, you as a application developer have the control in terms of defining the threshold beyond which a response won't be generated. Okay, so essentially, as I mentioned, that you have these are the categories: harm category, hate speech; harm category, sexually explicit; harm category, dangerous content; harm category, civic integrity. And you basically, Gemini internally will classify the content as being high, medium, low, or negligible, and then you can filter it. Block none, meaning it would just open the floodgates, which is probably not recommended, of course. Block only high is what we were showing. So it will only block the ones wherein, it sort of surpasses the probability threshold of the content being extremely unsafe. Okay, medium and above, low and above, and so on, and unspecified. Okay, so it uses the default. So essentially, this is the way you enable safety settings. Yeah, and when these LLMs are created on transformer manager long prompts and able to achieve multimodality. So I think just to functional. So again, I won't be able to comment on other available LLMs, but what I wanted to highlight here, right, is that there are, so I think when the early on models that were started or basically were introduced right from your GPT 2.0, GPT 3.5, and so on and so forth, there is like things started with text only models wherein it was text input, text output. And then I think the thing about Gemini is essentially in terms of the training. So when we say that it is multimodal ground up, essentially it is trained on all. you can say, types of data, whether it's audio, video, images, and text. So it is able to respond. Again, I think I probably have to go a little bit deeper, but let's say, for example, when you train a traditional text-to-text transformer, you'll have text in, text out. But in terms of doing videos, images, you will have respective embeddings that are generated for an image, or embedding that would be generated for video frames, embedding that would be generated audio, and then all of that get combined into a proper response that gets generated. So it's basically trained multimodal from the ground up, and that is what makes it extremely, you can say, useful when developing AI applications. Again, I won't be able to comment on the availability with regards to the other models. Sorry about that. What guardrails are in place to prevent bias or misuse of multimodal outputs? Again, I think this would probably go into in terms of like your usage agreements and stuff like that. Google does not allow you to use the outputs to be able to use it for, let's say, for example, distill or train a different model and things like that. It's not allowed. Multimodal prompts internally weigh the in multiple. Sure. No, so you cannot explicitly control the weighting, and to be very honest, it doesn't work in that same way. I mean, it's a fairly interesting topic of study on how, or rather, explainability and interpretability of some of these black box transformer-based models. The only way, or rather, the best way in which we have methods to control is by providing great prompts, great system instructions, making sure that your context is relevant and things like that. So as a developer using the Gemini model or the API, you need to be very, very crisp, very, very direct, relevant in terms of the prompt that you provide, and sort of the model is, as I mentioned, is pretty good to be able to do the rest. Awesome. There are many tokenization techniques. How are tokens generated? Are counted. So usually, I think, as I mentioned, so they have a library called tick token, and you can basically, each model can tell you which tokenizer, or rather which tokenizer method it uses, and tick token can count it for you. And also, as I mentioned, the GenAI SDK provides you with a function to be able to compute and count the tokens as well. So yeah. All right, I'll stop here. Thank you, folks. Thank you very much for joining in.
Thank you. Thank you so much, Sanjit, for taking out the time and being here. I can see there are so many questions and you answered most of them. So there's a lot of interest in the masterclass. So thank you so much for being here. And to everybody watching, thank you so much. And in case you missed out parts of this session, you can always access the recording on your dashboard. So with that, have a good evening, everyone. Bye.
Bye. Thank you.